Hello and welcome to part 4 of Nature of Matter. So we're going to be seeing part 4 now. We've already seen part 1, 2 and 3. In case you've missed out any parts, either 1 or 2 or 3, please go back and watch them before you come to this part of the chapter. So we've already studied about what are elements. We studied different kinds of elements. We saw difference in states of matter and kinds of matter. We saw how to represent elements, and we've seen what are metals, non-metals. So we've come this far in the chapter. So in this part of the video, what is it that we're going to be studying? So we will see characteristics of chemical combinations here. We'll see how exactly chemical combinations occur and what are their characteristics. We'll see properties of some compounds. We'll take a few examples and study those compounds in detail. And also we will introduce this new term called atoms. What are atoms? We'll be seeing the definitions of atoms. We'll see how atoms behave, and also we'll see how to represent atoms. Now we've seen that so far wherever we've learned something, we've also learned how to represent it. So we're going to continue the same thing. As and when we learn something, we'll learn how to represent it also. Let's see the first part, characteristics of chemical combinations. If you see characteristics of chemical combinations, there are two main characteristics that we are going to study. So the first one is elements combine in fixed proportion by mass to form a compound. That is, elements combine in fixed quantities. By mass means weight. By weight, they will combine in a fixed or constant proportion to form a compound. Now, if you see the very simple example that you observe every day in your lives, if you notice your mothers, she generally cooks everything in proportions, right? If there are only 3 of you in the family, she'll cook only for 3 of you. If there are 4 of you in the family, she cooks for 4 of you. So how does she cook exactly in these proportions? She makes sure that she adds 1 cup of rice, maybe 1 teaspoon of spice and 1 tablespoon of salt and things like that. So she has proportions for everything, 2 spoons of ghee. So she's very constant, and she has a fixed proportion of what to add and how much to add. So same way, if we have to get the compound that we desire, we have to add all the elements in the fixed proportion to get that. Now let's see this with an example. If you see this example right here, we'll take the example as carbon dioxide for the first one. So I've already told you before, CO2 means carbon dioxide. So this is carbon dioxide. So CO2. Now for carbon dioxide to be formed, we already know what are the two elements coming in. We have carbon, which is C. So this is carbon. And we have oxygen, which is the next one. So O is oxygen. So we have these two elements coming in to form a compound called as carbon dioxide, which we already saw in the previous part. So what is the fixed proportion that we're talking about? We said elements combine in fixed proportion. Over here, it says that 3 grams of carbon will mix with 8 grams of oxygen to give you 11 grams of carbon dioxide. So you see, this 3 and 8 are fixed quantities. You cannot change this in any ways. You can't make it 4 grams of carbon with 8 grams of oxygen. Then you won't get carbon dioxide, you'll get some other compound. So because this particular combination is fixed and the amount or the mass or the weight of carbon and oxygen is fixed, this is one of the characteristics of a compound. So if we have to see this more in detail, so 3 grams plus 8, 3 plus 8 is 11, so 3 grams of carbon, 8 grams of oxygen, you get 11 grams of carbon dioxide. Now let's explain this with a simple problem. Suppose they give us something like 44 grams. Let's say someone tells us that they're giving us 44 grams of carbon dioxide, and we have to find out how much carbon and oxygen goes into it. Now whichever sample of carbon dioxide you take, they will always be present in the ratio of 3:8. So they are always in the ratio of 3:8. That is, 3 will be carbon and 8 parts will be oxygen. So now they're telling us that we are giving you 44 grams of carbon dioxide. You find out how much of carbon and oxygen is present. So what will we do to find that out? We will simply divide this. Divide this by 11, because we know that the final product is 11 grams of CO2. So when you divide this by 11, what do you get? You get 4. So what we will do now, we know that 3 grams of carbon. Now this is multiplied into 4 because we have 44 as the end product. So we will do 3 into 4 of carbon plus, next is what? 8 into 4 of oxygen. So what is it that we get? Do the math here. So 4 threes is 12. So you need 12 grams of carbon plus, what is 8 fours are? 8 fours are 32. So 32 grams of oxygen will give you 44 grams. 44 grams of carbon dioxide. So this is how you do the math. So whatever is there here as the final that has been given to us, 44 grams, this is the final here that is given. This is the final compound that is given. So since we know this, we divide these two and we get 4. And then we multiply these proportions into 4 to get the amount that we desire. Even here, if you try to add, 12 plus 32 will be 44. So you get the correct answer. 44 grams of carbon dioxide will contain 12 grams of carbon and 32 grams of oxygen. Now let's see this with another example that may help you understand it better. If we take another very simple example of water, H2O is water. Wherever you see the symbol H2O, that means it is water. So if you see water, this has a fixed proportion. That is, only 1 gram of hydrogen and 8 grams of oxygen combine, it will give you 9 grams of H2O. This is the fixed proportion that is existing. So since over here we saw that the ratio of carbon is to oxygen was 3:8, over here it will be 1:8. So 1 gram of hydrogen, 8 grams of oxygen will give you 9. 8 plus 1 is 9. So 9 grams of water is what you get. So if we have to see another problem with this ratio, if they tell us that they're giving us 36 grams, let's say they tell us that they give us 36 grams of water, which is H2O, we have to find out how much of hydrogen and how much of oxygen is getting mixed. So what will you do to find out this? We will divide, just like how we did previously, 36 divided by this 9, because they're giving us the final answer. So 36 divided by 9 is what? What do you get if you divide 36 and 9? Again you get 4. 4 nines is 36. So same thing, you will multiply everything now. So how many grams of hydrogen do we need? 1 gram. So 1 into 4 of hydrogen plus how much of oxygen? 8 into 4 of oxygen should give you 36 grams of water. Let's do the math here. 4 ones is 4. So 4 grams of hydrogen plus, what is 4 into 8? 4 eights is 32. 32 grams of oxygen will give you, what is the total? 32 plus 4? 36 grams of water. Okay, so this is how we will be representing it. It's as simple as this. It's just simple maths. You have to just multiply everything with the correct number to get the correct answer. So I hope you've understood what this point means. It means that everything that has been added to a compound is in fixed proportions. If you try to add it in different proportions, you will end up with a different compound altogether. So this is the first characteristic we have. So what can we call this particular characteristic as? We can also say this phenomenon is the law of fixed or constant proportions of chemical combination. That is, this phenomenon where you have a fixed mass of adding the elements to get a compound is called law of fixed or constant proportions of chemical combination. So this is the first characteristic. What is the next characteristic? We'll see the next one now. So the properties of compounds are entirely different from those of its constituent elements. What does this mean? Let's see. the two examples that we'll consider here. One is carbon dioxide and one is water. We'll first see carbon dioxide. So what is carbon dioxide consisting of? It has carbon and it has oxygen. So carbon dioxide has both carbon and oxygen. So these two elements will combine to give you the compound which is carbon dioxide. So this is a compound. You already know carbon dioxide is a compound. So what does it say? The property of the compound, the property of carbon dioxide is entirely different from those of its elements. Constituent elements means the elements that it is made up of. So here carbon dioxide, if we are taking as the example, what are its constituent elements? Its constituent elements are carbon and oxygen. So carbon dioxide is made up of carbon and oxygen. So if you see property of carbon and property of oxygen, it is very different from the property of carbon dioxide. So the property of carbon dioxide will be very different from the elements that it is made up of. So what is water made up of? Water is made up of hydrogen. And what else is it made up of? Which is the other element that it is made up of? Oxygen. Okay, so water, if you can recall, is made up of hydrogen and oxygen. So these two are the elements which make up the compound called as water. So if you see the property of water, that it flows, it freezes, it melts and all of that, it's not the same when you see the properties of hydrogen or oxygen. Both of these have two different properties, but when they combine together to form the compound called water, this water will have an entirely different property. So that is what this characteristic is trying to say. It says that the properties of the compounds are entirely different from the elements that it is made up of. So I hope you have understood this. If you have to understand this more clearly, let's take up a chart and see how they function. So let's see this particular chart here. This explains to us exactly how they work differently. So the first one we're taking here is CO2, which is carbon dioxide. So if we see, first one is its element carbon. The color of carbon is black. It is in the solid state. The last one represents whether it will burn in air or whether it supports burning. Burning in air means it can catch fire and burn. Supports burning, it helps in burning something. So supports burning means it is helping something burn. So carbon, you know coal as an example, it is black in color, it is solid and it will burn in air. That we've already seen the picture of. Oxygen, is it colored? No, it's colorless. You can't see oxygen, right? You have oxygen all around you. Can you see oxygen in any particular color? No. So oxygen is colorless and it is a gas and it supports burning. In the absence of oxygen, you don't see burning happening. So generally oxygen aids in burning. There are a few other gases which help burning or which support burning, but oxygen is one major gas which supports burning. Whereas when these two combine with each other, what is the compound that is formed? The compound formed is carbon dioxide. Let's see the properties of carbon dioxide. So if you see the color, it's colorless. Okay, so here if you see, it is similar to that of oxygen. It's not black like carbon, but it is colorless like oxygen. And its state is generally gas, carbon dioxide gas. So here again the state is similar to oxygen. Whereas if you see burning or supports burning, it does not burn nor does it support burning. So here the property is completely different from that of its elements that it is made up of. So if you see these properties, they're totally different from the properties of its constituent elements. The same thing if we take another example of water, which is H2O. H2O is water. So what is water made up of as we saw? Hydrogen. So what are the properties of hydrogen? It is colorless because it's a gas. So hydrogen is colorless, it is a gas and it burns in air. You can set hydrogen on fire. What about oxygen? We already saw oxygen there. Oxygen is a colorless gas and it supports burning. When hydrogen and oxygen combine with each other to form a compound like water, what are its properties? Water is again colorless, but it is a liquid. It can be also a gas or it can be a gas. What is gaseous state of water? It is vapor or it can be a solid. So we have all three states. Can oxygen or hydrogen occur in all three states? Yes, if you do add pressure, you can make it exist in the liquid state, but then this is the most common type that you find, so we will state it only as gas. Whereas water, if you see, it is present in the liquid state, gaseous state and solid state. And again here, if you see the properties, it does not burn nor does it support burning. So here hydrogen burns in air, oxygen supports burning, whereas the compound that these two make does not support burning nor does it burn. You understand what the second characteristic is trying to say? It says that the properties of the elements that make up a compound are totally different from the properties of the compound. That is what it is trying to say. So we'll move on to the next part now. We'll start with something called as an atom. Let's introduce this term atom. So what we have right here, these two are two different atoms. I'm sure you would have seen this very commonly in most of these science videos. So this is how you represent an atom. Who's this? John Dalton is the person who coined the term atom. He was a British scientist who gave the term atom. So let's see what an atom is. An atom is the smallest part of an element that takes part in a chemical reaction. So the definition of an atom is that an atom is the smallest part of an element that can take part in a chemical reaction. Let's explain this with an example. What are these? What do you think these are? These are ice cream scoops. Okay, so these are ice cream scoops. If you walk into an ice cream parlor, we have various different flavors of ice cream. So we have strawberry ice cream, we have blackcurrant, we have chocolate, and we have mint. Okay, so these are the various flavors of ice creams that you can find in the ice cream store. Whereas, will the ice cream man give us half a scoop? No. So we have a fixed quantity of one scoop, right? We can't go smaller than one scoop. So this one scoop is nothing but an atom. Okay, so one scoop of ice cream is nothing but an atom. We can't go smaller than that. So one scoop is the smallest quantity you can get. So this represents an atom. If you add several scoops of one flavor of ice cream, suppose we add 3 to 4 scoops of just strawberry ice cream, you end up with a molecule of that element. Okay, so you end up with a molecule of that element. So what are we doing? Now one scoop is an atom. That is the smallest quantity that you can get. So you add many atoms together of the same scoop, you will get molecule of that element. Element is nothing but your flavors. Element is your flavors. So if this strawberry is hydrogen, this is oxygen, this is carbon, and this is, give me something else, let's say sulfur. Okay, so these are different elements and these are atoms of that particular element. It's the smallest particle that you can get in that element. So if we are adding all of H or all of strawberry ice cream scoops in a cup, you're getting a molecule of hydrogen. Okay, so you end up with a molecule of hydrogen. A molecule of hydrogen. What did we say a compound was? We said that a compound is something that is made up of various elements. So what happens next? Suppose I don't want just hydrogen. I want everything. When I go to an ice cream store, I want a scoop of every ice cream that I can lay my eyes on. So I have one scoop of strawberry here, one scoop of vanilla, one scoop of carbon. So when we have a mixture of atoms of various elements, we end up with a molecule of a compound. Okay, so we end up with compound. Over here, we're talking at the atom level. So we will say we end up with molecule of a compound. Okay, so we have one atom of hydrogen, we have one atom of carbon, we have one atom of say bromine. Let's say vanilla is bromine. So we are mixing all of these atoms together to get a molecule. So wherever there are mixture of atoms, we make a molecule. Because here all of the atoms are of the same element, we get a molecule of that particular element. Over here, if you see, we have different atoms coming in from different elements, so we get a molecule of a compound. So this is how we can easily remember the difference between an element, a molecule, an atom, and a compound. I hope it's very clear to you now. Now let's see the next part. We'll talk about characteristics of atoms. Now we've studied what atoms are. Let's see what are the characteristics of them. The first characteristic that we will study is the atoms of an element are all alike. Okay, so what does this mean? This means that if I pick out one atom of hydrogen or the second atom of hydrogen, all of them will be the same. It is much like the scoops of the ice cream from the strawberry jar. So if scoop 1, scoop 2 and scoop 3 are all the same. Don't you agree? Will there be any difference in taste or color or any of that? No, because they are all picked up from the same element. We are taking the same flavor strawberry, so we will get the same taste in all of the scoops. So that's what this means, that the atoms of an element are all alike. They will all be same. The second property that it says is the atoms of an element are different from those of another element. So one scoop of strawberry ice cream will be very different from one scoop of blackcurrant ice cream. Do you agree with me? This color itself is different, so is this color. Strawberry tastes totally different from blackcurrant. So same way, if you pick up an atom from hydrogen element and an atom from oxygen, they will be different from each other. So that is what this is trying to say, that the atom of an element are different from the atom of another element. Let's see what the third one is. The atom of an element will show all the properties of that element. So we just need to take one atom to know the property of that entire element, because that is the representative part. So you pick out one and you will know exactly how the rest of them are. So how do we say this? If we pick out one scoop of strawberry ice cream, we know exactly how that tub of strawberry ice cream tastes like. So just one scoop of it is enough to determine whether that strawberry ice cream is yummy or it's not yummy. So that is what this means. An atom of an element will show all the properties of that element. If this is pink, if this is sweet, and if this is tasting like strawberry, same thing will be with the scoop that is picked out of this, because this is a part of this. Okay, so the scoop is a part of the larger tub, which is the element. We're picking out the atom from it, which is a scoop. So it is the same. It is a representative part of this. We picked it out of the same thing. So we've already seen what atoms are. We've seen their characteristics. Now we have to learn how to represent them. Like how we've learned how to represent elements and we've seen what are the different symbols given to them. Same way we'll see how atoms are represented. An atom of an element is represented by the symbol of the element. So this is very simple. We've already learned the symbols of elements. So it'll be like a quick recap. Let's see. What is H? Is hydrogen. Hydrogen. So an atom of hydrogen is also represented by the H. Okay, by the alphabet H. Let's take another example. What does N stand for? N, nitrogen. N stands for nitrogen. So if you have an atom of nitrogen, you will represent it again with N. The next one, C, which is carbon. Next one, can you remember what Na is? It's taken from the Latin name of sodium. So Na is sodium. So you have sodium atom, which is represented by Na. Then you have O, the all famous O, which is oxygen, without which we wouldn't survive. Then we have Mg. What is Mg? Is it manganese? Is it manganese? No. No, it's magnesium. So Mg is magnesium, Ca is calcium, and the last example that we will see is Fe, which stands for ion. So these are how these atoms of these elements are represented. If you notice, they are all the same as the symbol of the element that we gave. Okay, so generally an atom, a single atom, is represented by the symbol of the element. So we'll go over it. H is hydrogen, N is nitrogen, Na is sodium, C is carbon, O is oxygen, Mg is magnesium, and Ca is calcium. Lastly, Fe is ion. So this is how we represent atoms. So with that, we finished this part of the chapter. We have one last part left. So let's see what all we've covered in this part of the chapter. We saw characteristics of chemical combinations. So under that, we saw two different properties. The first one we saw was that elements will combine in fixed proportions mass to form a compound. The second one that we saw was that properties of compounds were entirely different from the properties of the elements that they were made up of. Then we saw what are atoms. We saw that John Dalton was the one who coined the term atoms. We saw what the definition of atoms were. Then we moved on to what were the characteristics of atoms. So under that, we studied three main characteristics. That was that the atoms of an element are all alike, is what we saw. Then the second property that we saw was the atoms of an element are different from those of other elements. Then the third one that we saw was that atoms of an element will show all the properties of that particular element. And then the last part, we saw how to represent atoms. So with this, we complete this part. I hope you enjoyed it. If you have any doubts, please comment below. And please follow the next part of the chapter, which is the final part. Thank you.